Good afternoon, everyone. My name is Haley Hansen, and I am a senior in civil engineering here at the University of Wisconsin-Madison. And I am here with my fellow UW-Madison engineers, Tanner Carolyn, a senior in civil engineering, Briar Putz, another senior in civil engineering, and Clark Cantrell, a sophomore in aerospace engineering. And today we will be presenting about the Apollo 1 disaster. To start off this presentation, Tanner will take us through the details of what was supposed to happen during the Apollo 1 mission and what actually happened instead as a result of engineers neglecting the safety of the astronauts. Then Briar will take us through the ethics of the disaster and how people knew there was a potential for something to go wrong but did not act upon it. And finally, Clark will wrap it up with the long-term consequences of the disaster and how NASA changed as a result. Now I will hand it off to Tanner to start us off with the details of the Apollo 1 disaster.
Thanks, Haley. In 1961, in the midst of the space race, President John F. Kennedy gave his historic speech in which he set a lofty goal for NASA. He promised the American public that we were to land a man on the moon and return him safely to Earth by the end of the decade. NASA had already achieved spaceflight in the Gemini and Mercury missions. The Apollo mission was created as the first manned mission of the moon landing program. The initial Apollo 1 flight was designed to test out the setup by orbiting the Earth. The crew commander, Gus Grissom, was America's second person in space and was a commander on NASA's Gemini 3 flight. Ed White, Apollo's senior pilot, was the first American to make a spacewalk. Roger Chaffee was a rookie, yet was set to be the other Apollo 1 pilot. Grissom, White, and Chaffee were ready to be the first humans on the moon. After years of testing and planning, a rehearsal launch was set for January 27th in anticipation for the real launch scheduled for February 21st, 1967. The launch was meant to test ground tracking and control operations, as well as evaluate the performance of the rocket without ever leaving the platform. The crew loaded into the spacecraft and waited for instruction. The rehearsal was plagued with problems from the beginning. A foul smell arose from the oxygen tanks, and the communication systems were faulty. At 6:31 p.m., as the command team was preparing for countdown, a fire broke out in the cabin. Even though emergency procedures were set to only take about 90 seconds, it still took the rescue crew 5 minutes to access the command module. Within 30 seconds of the initial spark, Grissom, White, and Chaffee had died due to asphyxia from inhalation of toxic gases from the fire. Some maintain that President JFK placed immense pressure and a short deadline on NASA, as well as the contractor, North American Aviation, with his massively publicized speech. Some safety precautions were overlooked, and many fears and hesitations were ignored during the preparation. During Apollo 1's construction, the crew expressed their concerns as they realized much of the cabin's interior was made of flammable material. The inspector and engineers assured them that it would be all right, and little to no changes were made. The command module was fed with pure oxygen, because creating a dual gas environment required a system that was larger, and they would have to reconfigure the very small internal space. This meant that any spark would be fed by the 100% oxygen environment, and would likely spread rapidly. The exit hatch opened inward, making it very hard to open while the command module was pressurized. The hatch also did not have explosive bolts like past missions in case of emergency. The post-incident findings showed evidence of several sparks in the cabin. These were likely due to loose wires. NASA and North American Aviation made as many adjustments as they could before the rehearsal, but obviously not enough was done. The decisions made by those who worked on the Apollo 1 mission led to the tragic deaths of the crew members. Now I'll hand it off to Briar to talk about ethics.
Thanks, Tanner. With the pressure of the whole country on NASA to put a man on the moon before 1970, NASA brought in a massive number of engineers and scientists to work on the spacecraft. The engineering office was running out of space to put people, and some people even used doors set on sawhorses as drafting tables, because there weren't enough tables in the office. This collection of engineers and scientists were responsible for every decision that went into the Apollo spacecraft. Even to change one small component, there would have to be endless meetings and coordination between all of the engineers. This may have deterred engineers from bringing up issues that they thought were important, but that would have slowed down the engineering process considerably. Here are some facts that contributed to the Apollo 1 accident. Firstly, NASA was on a serious time crunch due to the challenge by John F. Kennedy to have a man on the moon by the end of the decade. This led to a very rushed engineering environment, as I explained in the previous slide. We also know that safety was not the #1 concern for the team, as they made a lot of assumptions that led to the accident, like overlooking the electrical components of the command module as a source of an ignition. When pure oxygen and flammable materials are put together, any small source of a spark would be devastating. Even though NASA knew of the risk of fire, they ignored the risk because they had no problems during the previous Mercury and Gemini missions. Of course, the people affected by the Apollo 1 disaster include those who perished in the fire: Gus Grissom, Ed White, and Roger Chaffee. Their families also grieved, along with the entire community that NASA had built with their spaceflight programs. Additionally, this incident put even more stress on NASA, as a year-long investigation was conducted on the command module, which slowed progress even more. The entire space program at NASA was affected as well, as it lost some trust from US citizens and had to prove that it was truly committed to safety as well as a successful lunar mission. The Apollo 1 disaster made NASA realize that they need to make a lot of changes to the command module to ensure that it provides the astronauts with a much greater level of safety in case of a fire. The first main change is that the interior needed to contain much less combustible materials, so that in the case of a fire, there would be more time for the crew to escape or put out the fire, as it would burn much slower. Along this point, NASA decided that they would use a less concentrated oxygen mixture for the air in the capsule when they were still in the Earth's atmosphere, and then change to a 100% oxygen mix for when the capsule left the atmosphere. This would also slow down the rate of combustion if a fire broke out during or before launch. The biggest change to the design of the command module was a total redesign of the hatch, which would allow the crew to open the door in 7 seconds, or for ground crew to open in 10 seconds. The original design was inwards opening, and since the pressure inside the capsule was greater than the pressure outside, it was impossible to open the hatch without first depressurizing the capsule. This was worsened by the expansion of gases during the fire, which increased the pressure on the capsule more and more until the capsule ruptured. Next, Clark will talk to you about the long-term consequences of the Apollo 1 accident.
Thanks, Briar. Hello, I'm Clark Cantrell, our risk analyst. I am here today to tell you about some of the risks if NASA did not learn from their mistakes, and look at what could have happened if NASA continued with their bad practices. Socially, this disaster added more stress to the Cold War between the USA and the Soviet Union. Americans had to admit that we were behind in the space race and we had to work hard to beat them to the moon. This was at the crux of the space race. We were at a major crossroads to see who would come out ahead. If we cut corners and ended up with another disaster, we would look like fools compared to the Russians, and they would see it as proof of the falls of our Western society. This accident caused us to put the program on hold for a whole year as we worked out the solution. If we did not learn from it and made careless mistakes again, it is likely that we would have fallen so far behind we would not be able to beat the Russians to the moon, and therefore lose the space race. This would, in return, greatly hurt public support for NASA. Financially, accidents like these hurt NASA a lot. NASA is funded by the taxpayer, and so their budget is up to the whim of politicians whose goal is to get re-elected. If the general public decides that NASA is cutting too many corners and wasting billions of taxpayer money, then those politicians would try to defund NASA. And with less money, NASA would not be able to keep up with the Russians, and they would seem like even more of a failure and get even less money. This loop of lack of funding and public support would mark the end of the space race as we know it. NASA would be financially ruined, and it would take years for it to get back in shape to compete globally. They needed to learn from their mistakes. The industry also needed to learn from this. We have a duty to make safety a priority. Progress at the cost of safety is not progress at all. The Apollo 1 accident was a main reason for the push for safety in all NASA procedures. Even rehearsals were things used to be assumed to be safe. Every step of a process had to have a robust plan for safety at every step. This added step is essential for the growth of space exploration as we know it today. In Chris Hadfield's An Astronaut's Guide to Life on Earth, an autobiography about his time at NASA, the thing he said that was the most important part of being an astronaut was not flying in rockets or practicing in your spacesuit. It was coming up with lists of everything that could possibly go wrong. That was the main job of an astronaut. They would spend most days just going over different procedures, finding out every mistake they could possibly make, everything that could randomly break. Then they would come up with solutions to fix them. This kind of thinking is directly a result of the different accidents at NASA over the years. If someone on the Apollo 1 program had thought of, hey, what would happen if the wire short-circuited during this training? Then maybe I wouldn't be here today talking about the ethical problems. However, even when you try, you cannot think of everything that can go wrong, as this would sadly not be the last NASA disaster. But we can see that it saved lives. When Apollo 13 was en route to the moon, one of its oxygen tanks exploded. However, the astronauts had been through countless scenarios, so they knew what to do and they made a plan. They were able to calmly come up with a solution and follow through with it. If NASA did not learn from the mistakes from Apollo 1, the whole pure oxygen atmosphere in the rocket would have gone ablaze if they didn't fix the technical side, but also the astronauts might not have gone over as many scenarios of possible failure, so they would not have been ready for when a real one happened. It is likely that the headlines about Apollo 13 wouldn't have been about their bravery and quick thinking, and instead be about another disaster. We have a duty to the astronauts and their families to learn from these mistakes and make their missions as safe as possible. Overall, our group agrees that safety is never something to be sacrificed. NASA did not go through the proper safety measures when they thought of this as only being a rehearsal. When working with rockets at the cutting edge of science, there is no such thing as being too safe. And now back to our team manager to wrap it up, Haley.
Thank you, Clark. So in conclusion, 3 American astronauts died on January 27, 1967 as a result of a fire that happened in the command module of Apollo 1 during a launch rehearsal. NASA engineers overlooked the potential issues with the electrical system igniting and starting a fire. They chose to adhere to the deadline rather than ensuring the safety of their astronauts. This inaction could have been a result of the immense pressure put on NASA by President Kennedy to win the space race, but nevertheless, never should have been allowed to happen. Fortunately, although at the high price of human life, NASA did learn a lot from their mistakes and implemented many changes, including increasing the testing and safety requirements and changes to the hatch doors and oxygen levels of future spacecraft. This allowed for success in their future missions and for them to become the NASA that we know and respect today. And that is all we have for you guys today. Here are some of the references that we used to compile this presentation. Thank you for listening to our presentation today, and now we will open up the floor for any questions that you guys might have.